Guys, welcome back. This will be the first video for Unit 8. If you thought you were done with stoichiometry, you're not quite done yet. So first, before we go on any further, we need to understand how to read equations. So you have the equation 2H2 plus H2O yields 2H2 plus O2 yields 2H2O. The coefficients, first off, are these big numbers out front. You should remember that from Unit 6 and 7. So the coefficients tell us that we have two molecules of diatomic hydrogens. That's what this means. We have two of the H2s that react with one molecule of diatomic oxygen. Remember, that's understood one. We don't have to actually put the one there. And that yields, remember that arrow means yields, or forms, or produces two molecules of H2O, or water. So those coefficients don't only tell us the number of molecules and formula units and atoms we have, they also tell us how many moles of everything we have. So we can also read it as 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. And you're going to be using those coefficients a lot because we're dealing more with moles, and now we're going to be going between two different compounds in a chemical equation. And if you want more detailed information, you can read through that chart on the bottom. But let's just go ahead and move on. So the law of conservation of mass. This is going to govern just about everything you do. So let's make sure we really understand it. So what does the law of conservation of mass state? It states that mass can either be created or destroyed, and the key thing is that it can be rearranged. We'll get more to that in thermodynamics, but to apply it to this unit, the mass of the reactants must equal the mass of the products. Now, a lot of people seem to take this for granted. We'll give you a very simple question like the next one, and they think they've got to do some real hardcore stoichiometry and some real difficult dimensional analysis, when really it's just a basic algebra math problem. So if we do it like this, in the example problem, 2 sodium nitrides yields or decomposes into 6 sodiums and 1 diatomic nitrogen. So if we start off with 500 grams of sodium nitride, we can say 500 grams, just like this, and complete decomposition to form 84.42 grams of diatomic nitrogen. How much sodium is produced? So we can say 500 yields some kind of sodium, or some amount of sodium, plus 84.42 grams of diatomic nitrogen. And so from here, it's just a simple math problem. We can even rearrange it and write it using equal signs. 500 equals x plus 84.42. So to rearrange this, I should be an equal sign, x plus 84.42. So to rearrange this, just use a little bit of algebra. It's added on the right, so you're going to do the opposite side and bring it to the left. Opposite of addition is subtraction. So 500 minus 84.42 equals 15.58 grams of sodium. So that's all it is. If you just remember, the mass of the products must equal the mass of the reactants. If it doesn't, you violated this law, and you've created matter, or you've destroyed matter, which we as humans cannot do. So if you, as long as you understand that, it's a very, very short video. We'll move on to get into more complicated stuff in the next one.